Check. Check. Sounds. These are sounds. Online students, can you hear us clearly? Can you hear me clearly? Cool. Let's hope today you are lucky. So, cool, yeah. So until others are here, let's start with question number 9 of that single page tute. Question number 9 of that single page tute. Let's start with the question number 9 of that single page tute. For the reference of online students, I'm talking about the make the tutes available in the YouTube live chat. Tutes will be available in the YouTube live chat and in the Zoom webinar under the section called resources. Okay, under the section called resources. So things will be available in the YouTube live chat now, and it's available in the resources section of the webinar and will be available in the group too. Okay, so get that single page. There's a small tute called how smart are you really? That doesn't mean actually you are smart if you are able to do this. But anyways, let's start with question 9. I mean, just until others come to the class. There's a bit of a lot of traffic down there, I think, at the entrance. So let's do a few questions until everyone is here. And did you do the homework? Did you do the homework? You're gonna start checking the homework now, okay? So that is a usual custom. So you have to do the homework every day, and we are gonna check homework every day. Students who did the homework? Okay. No, there's no such. I didn't give any homework, right? And anyways, we don't check homework much. Okay, you at this stage we expect you to have that level of intelligence to understand that you have to do yourself, not for ourselves. Okay, so we usually don't check homework a lot, but you have to do that. Okay. Start with question 9 of that single page tute, everyone. Did you find the tute? Yes, right? Did anyone didn't get the tute? Anyone who didn't get the tute? All right. Okay. Get the tutes. That single page one. No, the single page one. Yeah. Online students, were you able to find the tutes? Were you able to find the tutes? Anyone who didn't get the tute? Okay, we'll make the tute available. I mean, you can get the tute from the resources section of the webinar. Check the resources section of the webinar. You can get the tute from the resources section of the webinar. YouTube live students, you can get that from the YouTube live chat. Yes, it's available in the YouTube live chat. I'll provide that in the Zoom chat too. Provide the drive link in the Zoom chat too. If you didn't get that, you can get that from the Zoom chat too. We'll make that available in the Zoom chat. And at the same time, it's available in the groups. Come on, let's start. I don't see you doing anything. Question number 9 of this single page tute. Put a message if you didn't get the tutored. So you are in trouble. You accidentally paid for the wrong class in the website. Cool. You forgot my name, right? That's what happened. I'll ask one of my coordinators to do something about that. One of our coordinators have sent a message to you. They will handle that. Online students, whatever the issues you have, contact our coordinators. They will handle anything. So how was the other classes? Did you figure out your 3 classes? Yes? Did you figure out your 3 classes? Zoom recording? Did you figure out your 3 classes by now? Yes? If you have already chosen your 3 classes? Oh, a very small amount. That means I'm in risk, right? I mean, within a month, try to figure out the class, okay? Try to figure out the class. I mean, the 3 classes that you're going to continue, okay? Within a month, try to figure that out. Okay, what is in question number 9? What is in question number 9? And online students, we have delivered a lot of tudes, okay? So maximum within 2 days, you will receive everything, okay? Last Thursday and Friday, we posted the tudes. So they are not working on Sunday, so there's a small delay. But maximum by tomorrow or day after tomorrow, you're gonna receive all the tudes, okay? For sure. If you texted last week, okay? If you are just texting now, if you are sending a message now and don't expect us to send the tute, okay? We are not using missiles to send tutes. So, but if you texted last week requesting the tutes, maximum today, I think by today, a lot of students may have received tutes. By tomorrow and day after tomorrow, you're gonna definitely get the tutes if you messaged us last week, okay? Even though you paid or not, you're gonna get the tutes, okay? That's the story. Even though you paid or not, you're gonna get the tutes. Okay. So, anyone got the answer? 2 runners start to run from the position from the same point in a circular running track of radius 40 meters with a speed 1 meters per second and 5 meters per second. Find the time taken for the 2 runners to meet again. Okay. Are we good now? Sorry, online students, there's a lot of trouble here, a lot of traffic here. Would be normal by next week, okay? It's just the first few days. Oh, Agami, can't help. Okay. Okay, can't wait for everyone. Let's start. So, question 9 means 2 runners start to run. There's a circular track. There's a circular track like this. There's a circular track like this. Radius 40 meters. Radius 40 meters. One person is starting to run with a velocity of 1 meters per second. and the other one is starting to run with a velocity of 5 meters per second. Other one is starting to run with a velocity of 5 meters per second. Find the time taken for the two runners to meet again. So they are starting at the same point, time taken for the two runners to meet at the same point again. So, I mean, we can use different approaches for this question, okay? You did have relative velocity in your syllabus, right? Slightly. It was there slightly, right? Relative velocity, yes or no? Yes, right, in your O-level syllabus? As I remember, it was there. No. Okay, for you guys, it's yes. See? Different O-levels. Okay, so anyways, there's something called relative velocity, which is not rocket science. It is just the difference of two velocities. That means I can use different approaches to this question, but I can choose to think this in a different way, okay? I can choose to think this question in a different way. What is that? That is, if this person is running with a velocity of 1, if this person is running with a velocity of 5, what would be the difference between their velocities? It would be 4, right? So the difference between their velocities, delta V, would be 5 minus 1, which is 4 meters per second, right? Difference between their velocities would be 5 minus 1, which is 4 meters per second. Clear? It will be 4 meters per second. Now what actually happened is, this we call the relative velocity. That means what is the speed of the other guy compared to the first one. That is relative velocity. Clear? That means in the relative world, okay, one guy is stationary and compared to him, other one is running with a velocity of 4. Do you understand? That is the comparison, right? That is the comparison. Clear? In the relative world, one guy is stationary and other one has a velocity of 4 compared to the other one. Okay? Sure. Okay. What is the velocity of the other guy compared to the first one? It is 4, right? The difference between their velocities. So now what should happen is, for them to meet, this guy should run an additional circle to meet this guy, right? Clear? The one who's running faster should run an additional circle, okay? The one who's running faster should run an additional circle, to reach here again. Got the idea? Clear? Clear? So you have to do this, okay, if it's clear. Otherwise, those days, we can look at the eyes of the people and tell whether they understood or not. Now it's not like that. You just, whatever happens, you stays like that. So if you understand how to do this, if you not, you have to do this, okay? Basic instructions. Nowadays, you are not familiar with this stuff, right? Gen Z. Okay. So, so the velocity is 4, right? Velocity is 4. And that person should run an additional circle. That person should run an additional circle to reach here, right? For them to meet again. Then it's just about, you know that speed equals distance over time. Speed equals distance over time. Then we can tell time equals distance over speed. Time equals distance over speed. Then I can tell what is the distance that this person should travel. It is the circumference of the circle, right? Clear? So the radius is 40 meters, okay? Radius is 40 meters. So the circumference is 2 pi r, right? Circumference is 2 pi r. Circumference is 2 pi r. Clear? That is the length. and he's passing this length with a velocity of 4. Clear? With a velocity of 4. Clear? Then we get pi r over 2. Pi r over 2. Then pi is 3.14. Pi is 3.14. R is the radius, which is 40. R is the radius, which is 40 over 2. Over 2. Clear? Then this cancels out 1 and 20. Then we are gonna get 62.8 seconds. This is relative velocity in simple language. Okay, this is relative velocity in simple language. Clear? Two people are running, so the relative velocity is actually the velocity difference between them. That means 4. That means one person is running 4 meters per second faster than the other. Then for them to meet again, we should travel a one full circle. We should travel a one full circle. So the time is going to be the distance of a one full circle 2 pi r over the relative velocity 4. Clear? So pi r over 2. Then you simplify. Okay. So the main target here. Okay. Main target here is. Zoom out a bit. Main target here is like we are gonna learn these things as concepts. Okay. We are gonna learn these things as much better concepts. Okay. One by one. But the thing is, throughout this period, we are gonna make things much easy by showing that this is much simple than its word. Relative velocity is not a complex concept. Okay, it's just the difference. Okay, so while we are learning units and dimensions and measuring instrument lessons, we'll be ready for mechanics lesson. Mechanics is the first actual physics lesson. Okay, mechanics is the first actual physics lesson. So while learning this, while doing units and dimensions and measuring instruments lesson, every week we'll do few questions and make ourselves comfortable with upcoming mechanics concepts. Okay, little by little. So that is the main target. Okay, write this down. Let's move to the lesson today. Can I have a tute? Yes, it's also possible. So last week we stopped at supplementary physical quantities, right? We learned about the main classification of physical quantities. Okay, we learned about the main classification of physical quantities. Then today we have to go for prefix, multiplies and submultiplies. Okay, so let's move to the book. Okay, let's move to the book. Go to your book. Did everyone got their books? Anyone who didn't receive this? Anyone? Done? No. Okay. So let's move to the lesson. Let's move to the lesson. Go to page. Go to page 5. Go to page 5 of your book. Go to the page 5 of your book, everyone. This is something additional actually. So the people who came to the class now, you didn't miss anything, okay? You didn't miss anything. Okay. So starting. So last week we learned about units, right? Last week we learned about units. There are different units: meters, kilograms, centimeters, seconds, Kelvin, right? Sometimes some of these units are too large, or sometimes some of these units are too small. Okay. In this case, we have to make some units a bit larger or make some units a bit smaller. Okay. Clear? That is the idea. So as a result, we have submultiplies and multiplies. So if you look at your book, you can see octo, zepto, atto, femto, pico, nano, micro, milli, centi, deci. There's a bunch of submultiplies and multiplies. You don't have to remember these things. The most common multiplies or the submultiplies are, we can start with actually pico. Pico. What is pico? Pico is 10 to the power even I can't remember this stuff, okay? 10 to the power minus 12. 10 to the power minus 12. Okay. Then nano. We have nano. It is 10 to the power minus 9. 10 to the power minus 9. Then micro. Micro. Micro is 10 to the power minus 6. 10 to the power minus 6. Then milli. Milli. Milli is 10 to the power minus 3. 10 to the power minus 3. Then centi, 10 to the power minus 2. Then deci, that means 10 to the power minus 1. 10 to the power minus 1. Okay. So in this case, like this nano, micro, milli, these are just symbols used instead of numbers. Okay. That means instead of writing 10 to the power 6 minus 6 meters, instead of writing 10 to the power minus 6 meters, we write micrometers. That means micro equals this. Okay. Clear? Instead of writing 10 to the power minus 2 meters, we write centimeters. Clear? We write centimeters. So these are just symbols used instead of numbers. Okay. So quickly do these conversions. I mean, these conversions you can do in a separate book, in a piece of paper, on a leaflet, or if you like on your main book, whatever. Okay. Because I mean, it's just to make you comfortable with the concepts. Okay. So nothing complex. Just do these few conversions quickly. Write everything in meters. 10 micrometers, 10 to the power 3 millimeters, 10 to the power minus 2 centimeters, 10 to the power minus 2 centimeters, 50 nanometers. Convert everything into meters quickly. Not a big deal. Convert everything into meters quickly. So the idea is, I mean, some students are capable of, some students need some support on this kind of stuff. For some people, this is, way easier. So if you have time, try to finish this. Okay, if you're done with this, we have more tunes. Okay, so that's why I always bring resources such that it is enough for everyone. Okay, I always bring resources such that it's enough for everyone. So if you are capable of finishing things quickly, just go to this tute and try to finish this. Okay, there are some nice questions on this tute. Try to finish them. Try to think. Okay. And if you are struggling with these things, you can ask from our invigilators. You can ask from me, And at the same time, by next week, we are planning to start that session called Maths for Bio Student session. We are planning to start that by next week, okay? So by next week, we'll start teaching mathematics paths required for bio students, okay? But I mean, even though you are, even if you are doing maths, you can still join those sessions, okay? Because even though you are doing maths, still you haven't learned a lot of maths, okay? There's a lot of maths to learn. I mean, we are not gonna go into differentiation, integration kind of stuff, okay? But few simple concepts we'll learn for few weeks, okay? So online students, you are doing well, right, today? So in the initial these days, okay, before New Year actually, before New Year, we are gonna do these math for bio student sessions, and we'll arrange some invigilating programs separate. That means if you think that you were not good at maths, you can come to those invigilating sessions and like try to like ask these concepts from our invigilators. They will teach them from scratch, okay? A set of programs like that would happen, okay? Yeah, before New Year, a set of programs like that would happen, because I mean, we have to do everything possible to solve whatever the issues you had in O levels, okay? Okay, whatever the issues you had in O levels, we have to solve before New Year, okay? That is the target. New Year doesn't mean the next New Year, it's the April New Year, okay? Before the April New Year, we have to solve whatever the issues you had from O levels. Then everyone can be equal and start doing A levels properly, okay? So that is one of the main targets. So there will be a bunch of programs happening in the upcoming weeks, okay? To teach maths parts, some invigilating programs to teach you the things that you didn't understand well when you were doing O levels. Like that, a bunch of sessions would happen, okay? Try to join what is required. And same, all the programs will happen for online students too. Okay. So 10 micrometers. These things shouldn't be included in your short note. These things should not be included in your short note. Why? These things you are anyways going to remember after doing a lot of questions, okay? After doing a lot of questions, anyways, you are going to remember these things, okay? So there's no point of trying to remember these things, okay? So whatever we are going to remember in the future, we are not going to include them in the short note. Short note is meant for A levels, okay? We are writing the things that we will forget in the short note. That's all, clear? Things we will forget by A levels, okay? For an example, what are fundamental physical quantities? You will never see that coming again in the lesson, okay? In the syllabus. Now it's done. Nobody cares, okay? What are fundamental physical quantities anymore? I mean, that's how this moves forward, okay? So that you will forget with time. That should be included in the short note, because you are going to read the short note 2 months before the exam, okay? That's the target, okay? So many of the facts included in the tute will not be included in the short note, okay? Clear? So moving forward, 10 micrometers, 10 micrometers, 10 micrometers equals what? 10 into micro means 10 to the power minus 6, 10 to the power minus 6 meters, 10 to the power minus 6 meters. Then we get what? 10 to the power, this is 1. So how do we solve powers? It is 1 minus 6, right? We just add them. Can you remember? It is just 1 minus 6, clear? It is just 1 minus 6 meters. That means 10 to the power 10 to the power minus 5 meters. It's going to be 10 to the power minus 5 meters. 10 to the power minus 5 meters. Then the next one, 10 to the power 3 millimeters. 10 to the power 3 millimeters. 10 to the power 3 millimeters. That means 10 to the power 3 milli means 10 to the power minus 3. Milli means 10 to the power minus 3 meters. Then 10 to the power 3 minus 3 becomes 1, right? So 1 meter. 1 meter. Clear? Next one, 10 to the power minus 2 centimeters. 10 to the power minus 2 centimeters. That means 10 to the power minus 2. Again, centi means 10 to the power minus 2 meters. Clear? 10 to the power minus 2. Again, centi means 10 to the power minus 2. Again, meters. Clear? So we get minus 2 minus 2 minus 4. So we get 10 to the power minus 4 meters. Okay. We are going to get 10 to the power minus 4 meters. Then the next one. Next one. Yes, you can keep the answer like this. Why? I mean, because I mean, nobody cares. So, these are not A-level questions, okay? These are not A-level kind of questions, so you will never see this kind of stuff happening in A-levels, okay? This is just, I mean, common sense, developing common sense required for A-levels, okay? So nobody cares how you write this stuff, okay? So, 10 to the power minus 4 meters. Then 50 nanometers. 50 nanometers. 50 nanometers. So we get 50. Nano means 10 to the power minus 9, right? Nano means 10 to the power minus 9 meters. 10 to the power minus 9 meters. So you can maximum solve this like 5 into 10 to the power minus 8. Yes, right? 5 into this and this. 10 to the power minus 8 meters. Okay. So then we go to multiplies. We go to multiplies. If anyone finish this dude, let me know, okay? If anyone finish this dude, let me know. How did I got 5? 550. 50 means 5 into 10. Then 10 to the power minus 9. 50 is 5 into 10, then 10 to the power minus 9. This is 10 to the power 1. Then you get 5 into 10 to the power minus 8. Okay, that's how. Clear? No, the audio, yeah, audio was muted, yes. Then about multiplies. About multiplies. Okay, I know these stuff are easy for many guys. So they try to finish this tute, okay? They try to finish this tute. Okay. Okay. Um, then again multiplies. Sometimes our units are too small. Okay. Sometimes our units are too small to measure something. Then we have to increase the magnitude of our measurement. So we can get kilometers, megameters, things like that, right? That means in this case, I mean using meters. Okay. If I try to measure the length of a, I mean, even if I try to measure the length of this pen using meters, it is not much convenient, right? It's going to be point something meters, right? So I need a smaller measurement. That's why I need these stuff, okay? Centimeters, millimeters to make my unit shrink. Now sometimes I need to expand my unit, okay? Sometimes we need to expand the unit to measure the distance between two cities. Meters is not very convenient, right? It's convenient to talk using kilometers, right? Like that, sometimes we need to expand our unit, okay, based on the requirement. In such cases, we have multiples. These are deca, hecto, kilo, mega at page 6. Page 6. Mega, giga, tera, peta, exa, zeta, and iota. Okay? And don't try to remember these stuff. Commonly used things are kilo. Kilo. That means 10 to the power 3. Kilo means 10 to the power 3. Okay. Then the next one. Mega is usually used. Okay. Mega is usually used. Mega means 10 to the power 6. Mega means 10 to the power 6. Giga. Giga means 10 to the power 9. 10 to the power 9. Then usually tera, yes, you will see that. 10 to the power 12. That's all. These are the commonly used stuff. Okay. Don't try to remember. Okay. I mean, if you have to study something, I'll tell you. Okay. Don't try to study unnecessary stuff. Okay. Because you will have more than enough stuff to do in the future. So just live happily these days. Okay. So, I mean, so don't waste your time studying these days. Okay. Do something you like. Watch a TV series. Go for some day out, some trips. Okay. Live happily. Okay. It's a very short period of time that you're going to live happily. Then your life is going to be really bad. Okay. So just live happily these days. Okay. That's why I'm asking you not to study a lot of stuff. Okay. It's going to be a very small time period that you're going to live happily. Then after that you realize you're doing science. Okay. Then the real problems start appearing. Okay. Believe me. Okay. Believe me. For sure that's going to happen. Okay. Yeah. This is going to ruin your life. So just these days live happily. Okay. The best advice I could give. Okay. I mean, not joking, okay? This is quite serious. I'm quite serious, okay? I'm not joking. You'll see within few months, okay? So kilo 10 to the power 3, mega 10 to the power 6, giga 10 to the power 9, tera 10 to the power 12, okay? Then like that means kilometers means 10 to the power 3 meters, right? Megameters means 10 to the power 6 meters. We are just getting a larger unit. That's all. Clear? We are just producing a larger unit. So quickly write 50 megameters, convert it into meters. 30 kilometers, convert this into meters. 10 to the power 3. 10 to the power 3 gigameters, convert this into meters quickly. I mean, you can use a leaflet or something, okay? Just get all the leaflets you are getting from at the entrance. You should do something like at the entrance, if people give two side printed leaflets, reject them. If people give one side printed leaflets, get them. Then they go and tell their teachers the people are not getting one side two side printed leaflets. Then they start giving only one side printed leaflets. Okay, then you always get a bunch of papers that you can work on. Okay, so do that thing. Reject two side printed leaflets. Reject everything. If there's one side printed leaflets, get them. Okay. So it's 50 megameters, 30 kilometers, and 10 to the power 3 gigameters. So how to do the conversion? 50 mega means 10 to the power 6. Mega means 10 to the power 6 meters. Then 30 kilo means 10 to the power 3 meters. Then 10 to the power 3 giga means 10 to the power 9. Giga means 10 to the power 9 meters. Clear? Ah. So we can write this. This 0 also I can give here, right? I can connect this 0 to this one. Then I get 5 into 10 to the power 7 meters. Or you can just keep it like this, okay? Then this 3 into 10 to the power 4. You get this 0 to this one. 10 to the power 4 meters. Then here you get 3 and 9. So you just add the powers. So 3 plus 9. 3 plus 9. 3 plus 9. That means 10 to the power 12 meters. Okay. 10 to the power 12 meters. So quickly do these conversions next. If you have any questions, let us know, okay? If you have any questions, let us know. Ten to the power 3 millimeters convert into megameters. 10 to the power 4 micrometers convert into gigameters. 10 to the power minus 2 megameters convert into nanometers. 10 to the power minus 6 kilometers convert into micrometers. Quickly. Online students, any questions? When are you getting the tunes? I mean, we posted everything, okay? So do you do practicals in the class? Yes, there's going to be two types of practical setups in the class, okay? We are planning a new, like, even a new studio to do the practicals and demonstrate them properly, okay? So the practicals will be entirely new process this time. Yes, sure. Online students can join those practical sessions live. You had big match, right? Some people? Yes, any questions? Any questions quickly? Did I make any mistake? I'm not good at these kind of stuff, okay? So there's a small chance of me making mistakes on this kind of stuff. Question? It's megameters. In the third one, it's megameters into nanometers. Okay. So I mean these stuff, I mean soon you're gonna do this without writing any step. Okay, that is the main target. Okay, because I mean we don't have enough time to do write steps for these stuff. Okay, we have more than enough work in a level paper. Okay, so we don't write steps for these stuff. Okay, so you just see and you just write that. That's all. Clear? If you need to convert 10 to the power 3 millimeters into megameters, you somehow just write that. That's how it should happen. Okay, it may not like that at the moment. Okay, for some people it will take some time, but that is the goal. Okay, just to be familiar with this stuff. Okay, but anyways, if you are struggling, okay, if you are struggling to write this directly, okay, if you are struggling to write this directly, we can do something like this. Okay, we can use some steps for this. How? 10 to the power 3 10 to the power 3 millimeters equals x megameters. I mean, at the moment, it's okay to do something like this, follow steps and go for the answer. But in the A-level paper, the person who's marking your paper, see you have done something like that. I mean, they are going to somehow find you and send you to do scholarship or something like that again, okay? So we don't write steps for these kind of stuff in A-levels, but just for now, to just until we get familiar, it's okay to write this kind of stuff, okay? Clear? Ah. So 10 to the power 3 millimeters equals some number of megameters, right? Equals some number of x number of megameters. Clear? So we get 10 to the power 3 milli means 10 to the power minus 3, right? Milli means 10 to the power minus 3 meters equals x. Mega means 10 to the power 6, right? Mega means 10 to the power 6 meters. Clear? Mega means 10 to the power 6 meters. So this is mega means 10 to the power 6. Clear? Then we get, I mean, now it's meters and meters. You can solve for x. X becomes here 10 to the power 3, here 10 to the power minus 3, then divided by, you take it here, divided by 10 to the power 6. Okay. Divided by 10 to the power 6. Clear? 10 to the power 3, 10 to the power minus 3, you take it here 10 to the power 6. Then you get 10 to the power 3, 10 to the power minus 3, then you take it up 10 to the power minus 6. You take this up 10 to the power minus 6. Clear? You take this up 10 to the power minus 6, then 10 to the power, you just add the powers 3 minus 3 minus 6. Okay? You add the powers 3 minus 3 minus 6. Clear? Then you get 10 to the power minus 6. So x equals 10 to the power minus 6. That means, so 10 to the power 3 millimeters equals 10 to the power 3 millimeters equals x is this. This is x. So 10 to the power minus 6 megameters. Clear? Got the idea? So you never write these steps, okay? You just go from here to here, okay? You just go from here to here. Don't try to write steps. But for now, until you get familiar, it's okay to write steps, okay? Got the idea? It's just for now, okay? Clear? So if you are writing steps for these things, there's a trouble, okay? Not now, okay? Not now. But when you're at A levels, okay, if you have to write steps to do this, that means anyways you are not going to be able to do anything else in the paper. So if you can write this directly, write that directly, okay? If you can, I mean, it anyways depends on the person's capacity at the moment. So if you can write this directly, just write it directly. Otherwise, it's okay to use steps now, but with time you have to get rid of the steps and directly go from here to here, okay? Yeah. Then next one. Just let me know if you need me to explain anything again. 10 to the power micrometers into gigameters. 10 to the power 4 micrometers into gigameters equals x number of gigameters. 10 to the power 4 micrometers equals x number of gigameters. Okay. So again, same steps. 10 to the power 4. Micro means 10 to the power minus 6. Micro means 10 to the power minus 6 meters. Here x, giga means 10 to the power 9. 10 to the power 9 meters. Now it's meters and meters, so I can solve this. So x equals here 10 to the power 4, here 10 to the power minus 6, then divide by 10 to the power 9. Divide by 10 to the power 9. Clear? So we get 10 to the power 4 into 10 to the power minus 6 into 10 to the power minus 9. Okay. 10 to the power 4, 10 to the power minus 6 into 10 to the power minus 9. Clear? Then you just add these two. 4 minus 6 minus 9. 4 minus 6 then minus 9. So what do we get here? It's 10 to the power minus 11, right? 10 to the power minus 11. So x is 10 to the power minus 11. That means 10 to the power 4 micrometers equals 10 to the power 4 micrometers equals x means this 10 to the power minus 11. 10 to the power minus 11 gigameters. Gigameters. There was a question online like how to figure out a proper class. That means how to check whether the class you are going is good. I mean, I don't know. Just ask from seniors. Seniors would always give better recommendations. Okay. Ask seniors what actually happened. Okay. And like some other facts, if someone is trying to emphasize that their class is good, there's something fishy. Always see what is happening. Okay. Just a basic guideline. Okay. If someone tries to explain why that class is good, okay, why my class is good, if too much emphasis happens on that, that means there's something fishy. Okay, you have to check. Okay, clear? I mean, obvious, right? I mean, you just go for a class by listening to seniors, looking at the program, looking at everything, and you go to the class. Then the person don't have to keep telling why the class is good. Okay, so if someone keeps telling that their class is good, there's something fishy. What else? What else about choosing a class? I don't know. There should be enough count, like enough competition actually. Enough competition. You can't be in a class where you have 20 students and be the class first within that 20 students and be happy. Okay. Good students should be writing that paper. Okay. Good students must write that paper. I mean, whatever the paper or anything. If we give an exam here, good students must write the paper. Clear? There should be enough number of students writing the paper so that you know what is your actual level. Otherwise you can be a hero in your 15-member class, okay, and still get a F. Okay, clear? Clear? So there should be enough count and enough competition in the class. That is essential. Okay, that's a must. Okay. So in our class you will find a huge competition because I mean there's people all around the country. There's a separate batch of Sinhala medium students writing the papers. So there's a huge competition. Okay, competition is not with the English medium students. It's with all the students, including Sinhala and English. Okay. So like this, that there's a bunch of things that you have to check when you're choosing a class. I'll talk about that later. Okay. මතක් වෙන වෙලාවට කියන්න. Oh, can I recommend a class? No. Don't do that here. My class is actually good. Okay. Then 10 to the power minus 2 megameters. 10 to the power minus 2 megameters. Megameters into nanometers equals x into nano means 10 to the power minus 9. Sorry. Let's first write the first step. X into 10 to the power minus 2 megameters equals x into nanometers. Nanometers. Then we get 10 to the power minus 2 mega means 10 to the power 6 meters. 10 to the power 6 meters equals x into nano means 10 to the power minus 9 meters. Nano means 10 to the power minus 9 meters. Mega is 10 to the power 6. 10 to the power 6. Then x equals 10 to the power minus 2. 10 to the power 6 divided by 10 to the power minus 9. Okay. Then we get 10 to the power minus 2, 10 to the power 6. We take this up. So we get 10 to the power 9. 10 to the power 9. Then we get this 10 to the power 13, right? 10 to the power 13. We get 10 to the power 13. So 10 to the power minus 2 megameters equals x means 10 to the power 13. X means 10 to the power 13 nanometers. 10 to the power 13 nanometers. Clear? Oh, what was here? What we had here? It's 10 to the power minus 6 kilometers into micrometers, right? Is that correct? Okay. Just give it here. Next, 10 to the power minus 6 kilometers. Ten to the power minus 6 kilometers equals x micrometers. 10 to the power minus 6 kilometers equals x micrometers. Okay. Then 10 to the power minus 6 kilo means 10 to the power 3. Kilo means 10 to the power 3 meters equals x. Micro means 10 to the power minus 6 meters. Then both sides are in meters, so I can solve. X equals here 10 to the power minus 6, 10 to the power 3, 10 to the power minus 6, 10 to the power 3 divided by 10 to the power minus 6. Okay. 10 to the power minus 6, 10 to the power 3 divided by 10 to the power minus 6. So this cancels out. You get 10 to the power 3 meters. Sorry, 10 to the power 3. X has 10 to the power 3. 10 to the power minus 6, 10 to the power 3. You take it here, 10 to the power minus 6. Then you have 10 to the power 3. That means 10 to the power minus 6 kilometers. 10 to the power minus 6 kilometers equals x means 10 to the power 3. 10 to the power minus 6 kilometers equals x means 10 to the power 3 micrometers. 10 to the power 3 micrometers. Clear? Got the idea? Okay. Let's move forward. So everyone definitely write your like WhatsApp numbers, because I mean We don't know when we have to shift into online classes. Okay, one nuclear bomb is all you need. Okay, so definitely write your WhatsApp numbers. Okay, I mean that happened. 21 batch paper class. On the first day, we collected the WhatsApp numbers. After that, it was locked down, as I remember. So if we didn't collect the WhatsApp numbers that day, the class have to be halted that day. But anyways, we continued because we had the numbers, so we sent messages with the Zoom and Zoom links, and we continued the class. So we are really close to that kind of scenario. So write the numbers. So we can continue things online. Mali, Mali. Okay, pay attention, everyone. Pay attention. Okay. So there are methods of expressing SI units. We'll just quickly go through these things. Things like when a unit is named after a scientist, it should be capital. Okay, Kelvin, Newton, Ampere, Pascals. Okay, page 6. Page 6. Okay, Kelvin, Ampere. Pay attention. Stop talking. Pay attention. Kelvin, Ampere, Pascal. All these units are capital. Okay, because it's about a person. Then you don't have plural forms of these units. It's not kilograms. Okay, it's kilogram. Okay, it's 5 kilograms. You're not gonna put a S here. Okay, these are basic stuff. Okay, and this, I mean, I mentioned that this kilo, mega, nano is just something used instead of a number, right? But you can't write it anywhere. Okay, okay, that means this is kilograms. Okay, this is kilograms. Okay, this is not kilograms. Okay, this doesn't mean 10 to the power 3 into grams. Okay, this means nothing. Okay, okay, it's just kidding. Okay, then so you just have to write things in the proper order. Pay attention. Then you don't write a space here. You don't keep a space between kilo and grams. Okay, you don't keep a space there. Clear? Then the next one is uh, you can't use these things again and again. That means you can't use kilograms. Okay, it's not gonna happen like that. It's only one prefix. Okay, then again you should write a space between 5 and kilograms. That means the number and the unit. Between the number and the unit, you should put a space. Okay, you should put a space. Then when there is a bunch of new units, when there's a bunch of units, there should be a space. That means Newton meter should be written with a small space. Okay, Newton meter should be written with a small space. Okay, when it is a combination of a set of units, when it is a combination of a set of units, you should keep a space between them. Okay, you should keep a space between them. Then yeah, so these are the facts. Okay, so should you follow these rules when writing things? No. Okay, because again nobody cares. I mean, we have more than enough work to do. Okay, in A-level paper. So the people who are marking a paper, or they also have more than enough work to do. Okay, so they are not going to care whether you follow these things or not, whether you are keeping the space here, whether you are having a space here. Nobody cares, but just know them as rules. Okay, clear? Just like the rules in Sri Lanka. Okay, so So there are rules, just know them as rules, but you don't have to follow, okay? But that doesn't mean you can write this, okay? That doesn't mean you can write this, okay? It's basic common sense that you can't write this. Otherwise, do you have to think about having a space here? No, okay? Do you have to think about having a space here? No, okay? Clear? Nobody cares, okay? So that's the idea. Just know them as rules. Don't try to follow them. We have more than enough work to do, okay? Moving forward, general features of a unit. General features of a unit. These are quite important, okay? There are some features of units. First thing is units cannot be added, okay? Units cannot be added. That means you can't add 5 meters to 3 kilograms and add the units and get something, okay? This doesn't make sense, okay? Clear? This means nothing. You can't do this, okay? Clear? You can't just add units and get something, okay? You can't add meters with kilograms. You can't subtract, okay? You can't add or subtract units. Clear? You can't add or subtract units, and at the same time, units can be multiplied, okay? That means 5 newtons and 3 meters means 15 newton meters. Clear? 15 newton meters, okay? Then 5 kilogram over 10 meter cube. 5 kilogram over 10 meter cube means 0.5 kilogram per meter cube. Kilogram per meter cube. So units can be divided, units can be multiplied, but not added or subtracted. Clear? Then the next one. For an equation to be correct, both sides of its units should be same. For an equation to be correct, both sides of its both units of both sides should be equal. That means x number of meters can be equal to y number of meters, then x is equal to y. Or you can write equations. Can you remember pressure equals h rho g? There are equations like this. Force equals ma. Okay. Pressure equals h rho g. Force equals ma. In these kind of all these equations, okay, all these equations, the units in this side must be equal to the units in this side, okay? That means pressure is measured in pascals. When you combine all of these, you should get pascals again, okay? Force is measured in newtons. When you combine all of this, you should get newtons, okay? That means for an equation to be correct, units of both sides should be equal. And it's again common sense, right? 10 kilograms cannot be equal to any number of meters, right? Clear? Okay. 15 Kelvin cannot be equal to any number of seconds, right? Clear? So anyways, for an equation to be correct, the units of the both sides must be same, right? Clear? Units of both sides must be same. Got the idea? Clear? Then moving forward, next. Six and seven, these are not main theorems. Let's go to eighth one. Eighth. Like for a equation, I mean, if there's a equation with multiple components, did you have any equations with multiple components? No, right? In O levels, b squared plus equals u squared plus 2a, things like that. You have anything? No, right? Anyways. Okay, I'll explain on how to join the class and know for online students. Like, and someone's in a hurry, what happens to the paper writing stuff? Oh, yes, that's why I said asked you to live happily these days. I mean, the papers, all the kind of stuff are going to happen soon. So, eighth, I mean, take this example, SC equals UT plus half AT squared. There are these kind of equations, okay? You will have thousands of equations like this. For an equation like this to be correct, Units of each component must be equal, okay? Units of each component must be equal. That means units of this must be equal to the units of this, must be equal to the units of this, okay? Units of this should be equal to the units of this, should be equal to the units of this. Clear? Units of three components must be equal. Clear? I mean, it's quite obvious. Why? You first add these two. You can't add 5 meters to 3 kilograms, right? For that to happen, you need equal units. Clear? When you add the equal units, you are getting something with the same unit, right? When you add the equal units here, you are getting something with the same unit. Clear? You are gonna get something with the same unit. So anyways, that should be equal to the unit in this side. Got the idea? Okay. So yes, for a equation to be correct, units of all the components should be equal. Clear? Then moving forward, when it comes to sine terms, cos terms, tan terms, definitely this is an angle, right? Definitely this is an angle. Okay. This is an angle. So measured in radians. Angles are measured in radians, if you can remember. And today we'll add you to groups. Any new students? The last week session is there. So we will add you to the groups today after the class. Then provide last week's recording to watch that. Okay. New students, watch last week's recording. We'll provide that in the group. And for any new student to join the group, contact this number, 070-154-6825. Just put a message to this number, 070-154-6825. And there's another number to get your tunes delivered. I'll put that in the board after a while. Okay, just put a message to this number. So moving forward, but this sine term together cannot have a unit, okay? This can't have a unit, okay? This can't have a unit. That means theta has a unit, that is radians or degrees. Angles have units, but sine theta can't have a unit. It's obvious. Why? It's length divided by a length, right? Sine theta is divided by dividing a length by another length, right? This is theta, this is x, y, z. Then sine theta is what? X over z. You know these things, right? Yes, right? Sine theta is x over z. That means length divided by length. So the units cancel out, right? Sine theta, cos theta, tan theta, everything is a length divided by length. Okay. So they cancel out. Clear? Then why do we learn all this stuff if we actually don't get questions like this? I mean, again, just for common sense. That means even in a question, you can check whether the answer you got is correct or not by comparing the units. Clear? In MCQs, you can check the answer you got whether it's correct or not by comparing the units. Clear? I mean, if they're asking a pressure, after combining all the values, you are getting an answer. But if the unit of that answer becomes newtons, then it's a problem, right? Then you are missing something like that. Just to check your answers, just to check whether you are doing everything properly, just to check the equation you derived is correct or not. For these kind of stuff, we need the common idea or the common sense of units, okay? See, otherwise you will never get questions related to this, okay? So, sine theta is unitless, right? Because it's a length divided by another length. Then moving forward, again the powers can't have units, okay? Powers can't have units. Log term can't have units. Again, this is common sense. You can't have 10 to the power 5 kilograms, right? It means nothing, right? 10 to the power 5 kilograms, that means nothing, right? I mean, 10 to the power, it should be just a number, right? Always. 10 to the power 5 means something, right? 5 to the power 4 means something. 3 to the power 2 kilograms. I mean, it can't be anything, right? Clear? So you can't have a unit for the power, okay? You can't have a unit for the power. Then, I mean, again, it's common sense, right? Why are we telling these things? Okay, for an example, there's an equation that you should derive in the last lesson called matter and radiation. In the last lesson called matter and radiation, okay, there's an equation that you should derive, that is how fast a radioactive particle decays. Okay, how fast a radioactive particle decays. In that equation, you have the number of radioactive particles as n, the starting number of radioactive particles as n naught, E minus lambda t. You derive an equation like this on the way, throughout the process. After deriving this equation, okay, after deriving in this equation, you get a constant here. You don't know anything about this constant. What is this constant? How that constant functions? You have no idea. Then we try to figure out what is this unit? What is this lambda? What is this constant? What is its behavior? We can start understanding that by getting the unit of it. You know the unit of lambda. What should be the unit of lambda? T is time. T is time. Then what is lambda? 1 over time, right? That means if the unit of time is seconds, then unit of lambda should be 1 over seconds, right? Take this, unit of time is seconds, then unit of lambda should be 1 over seconds, right? Then only units cancel out and I'm not getting a unit here. I can't have a unit for a power. I can't have a unit for a power. Clear? And time is measured in seconds. Okay? Time is measured in seconds. Then at the same time, I have no idea about this constant because this is an experimental process. We do a small experiment and try to figure out the equation. Through a bunch of experiments, we get this equation. So we don't have a very good idea about these components in radiation. Then we try to figure this out. We start understanding about that lambda by understanding the unit of it. So we go for the basics again. In the last lesson, we return to the first lesson again. Then see what can we know about lambda. Then we remember the first thing we learned in the syllabus. Okay. Then I mean, all of a sudden you start getting memories of how your life looked to be on those days. You were really happy those days, kind of stuff. All of a sudden comes to your brain. But at the same time, you remember, so okay, a power can't have a unit. Clear? A power can't have a unit. Clear? While remembering about how your life was so good, kind of stuff. At the same time, you remember power can't have a unit. So if time is measured in seconds, lambda is 1 over seconds, right? Clear? Then as the first thing about this unknown lambda, the first thing you understand about this is the unit of this lambda is 1 over seconds. Clear? 1 over seconds. That means the unit of lambda is per second. Okay? Unit of lambda is per second. What is measured in per seconds? Hertz is per second. Can you remember? Did you have this kind of stuff in all levels? Per second means how many per second? Or else we gave a nice name to that called Hertz. Yes or no? Did you have this kind of stuff? You had this in all levels? Raise your hand. Okay, cool. Okay, so we first figure out, okay, there's someone called lambda. Its unit is per second or hertz. Then we know something about lambda. Then we can start experimenting on that. See, that's when we need the rules of units. Even in the extreme modern science, we use these concepts. Why? Using modern science, modern experimental systems, very complex stuff, we somehow try to create a equation. But whenever you create a equation like that, it's a partial equation. You don't know everything. Then you use a bunch of mathematics to understand the area. Then you use a bunch of mathematics to understand, then you use a bunch of mathematics to understand a certain area of that equation. You use these kind of rules to understand a certain area of that equation. See, that's why we need that common sense, okay? Why? Even in extreme modern science, you can't have a unit for the power, okay? Clear? After thousands years, we will have a extreme science, okay? Quantum mechanics kind of stuff will improve and we will have an extreme level of science. But in that science also, a power can't have a unit, okay? Clear? That's why we are learning these things now, okay? Not because they are going to ask questions from that. Just because you need this knowledge for a lot of other stuff, okay? So moving forward, you can't have log terms, you can't have units in a log term. That means you can't find 10 to the log, you can't find log 10 of 5 kilogram. Means nothing. You can't get log of a unit, okay? You can't get a log of a physical quantity. You can only get log of a value, okay? You can only get log of a value, okay? That means you can only get log 10 to the power 5, not 10 to the power 5 Kelvin, not 10 to the power 5 second. You can't get the log value of a physical quantity. You can only get log of a number. Clear? Then as a result, the output of the log value, the output of a log value also unitless. Okay? The output of a log value that you are getting from the logbook is also unitless. Clear? Got the idea? So that's how it works. So in your book, in page 13, log is not a unit. Log is a mathematical function. No, you don't have to put a message to the WhatsApp number. If you pay, the admins will do the rest. Anyways, the tunes will be to get the tunes couriered, you have to put the message, okay? Here. Exercise 2. Exercise 2. Go to question 4. Five. Eight. In 8, Q is energy. Energy is measured in joules. Heat is a energy. 11. Try these questions. So to join the group, online students, put a message to this number and you can get the recording to 070-154-6825. You can get the recording to 070-154-6825. You can get the recording to. So do you have classes on Tuesday mornings? Who have something to do on Tuesday morning? Yes, some people have school. Raise your hand properly, because I mean we are just trying to plan the sessions. Okay, thank you. And I'll give another question. F equals A M e to the power A R T A R T plus F over B. These are some additional questions, okay? These are some additional questions. Exercise 2, try question 4, 5, 8 and 11. Question 4, 5, 8 and 11. Then you have an equation like this. Pay attention. F over B equals A M E A R T. Here E is just a number, okay? E is just a number, or else let's write 5 here. 5 to the power A R T. Then I need you to find the unit of B. I need you to find the unit of B. F is a force, M is a mass, R is radius, T is time. Okay? F is force, M is mass, R is radius, T is time. I need you to find the unit of B. Try to find that too while doing these questions. Exercise 2. And online students, if you have any questions, if you need me to explain anything again, just mention in the chat. Mention in the chat if you need me to explain anything again. A and B are unknowns. A and B are unknowns. If you like, you can use a separate book for the exercises, or you can use the same book. Okay. Clear? And again, for online students, a special program would happen. Another series of sessions would start happening. Okay. Most probably, I'll be starting another separate online class. Okay. I'll inform about that in the group and all. Okay. Most probably, we'll start another separate online class too, with smart boards and everything at a proper platform. I'll inform that in the group and all. For now, let's continue with this class. You can find the exercises in the resources section. In the resources section of the webinar, you can find these tutes. Go to the main tute. Go to the main tute. In the main tute, you can find exercise 2 in page 13. Okay, you can find the tutes in the group. I'll put them on the YouTube live chat again, and put it in the Zoom chat again. Put the link in the Zoom chat again, and again in the group too. Put it in the group too. So you can get the tutes from the group, from the Zoom resources section of the Zoom chat, or resources section of Zoom, and again it will be available in the Zoom chat too. Then or from the YouTube live chat. And online students, you will receive the tutes within 2 days. Okay. And online students, classes will happen through the CCG platforms. Okay. So register through the CCG platforms within this week. Okay. Register through the CCG platforms within this week. There are 2 CCG platforms. If you are joining physically and online together, or then you can join through one platform. If you are joining online only, you can join through another platform. All the information will be available in the group. Put a message to this number to get the information. Okay. So set up your websites and be ready to join through the CCG platforms from next week. Okay. It's same. You will be redirected to the Zoom meeting, but through the CCG platform. Okay. That's how it's gonna continue. You will be redirected to a Zoom meeting and our website portal when you join through the CCG platform. Okay. So make your websites ready. In the future, all the papers are submitted online. They are marked online, timers, MCQ submission and answers, online invigilating programs, everything would happen through the CCG platform. So within this week, set that up. Okay. Set up the CCG platform. We'll make the information available in the group. Okay, moving forward, let's do the questions. Let's do the questions. Exercise 2. Exercise 2. Question 4. Exercise 2, question 4. F equals G M1 M2 over R squared. G M1 M2 over R squared. F equals G M1 M2 over R squared. If F is the force, M1 M2 are masses, R is the displacement between the masses. What is the unit of G? So you first get G here. G is FR squared over M1 M2. So how do you get the unit? F is force measured in newtons. F is force measured in newtons. Clear? R is a length. Clear? Okay. F is measured in newtons, right? R is a length. Length means meters, right? Length is measured in meters. Clear? So length squared. R squared means meter squared. Clear? Divided by M1 and M2. What is M1? It's a mass. Clear? That means measured in kilograms, right? Measured in kilograms. Then again, this is also measured in kilograms, okay? This is also measured in kilograms. Clear? Got the idea? So we are gonna get Newton meter squared per kilogram, like this, right? I mean, I'm gonna write this as Newton meter squared kilogram squared. Newton meter squared kilogram squared. Then I'm gonna take this up. Then I'm getting Newton meter squared kilogram minus 2. Clear? So this is the unit of G. This is the unit of G. Yes, if you like, you can solve this further, okay? If you like, you can solve this further. How? I mean, but this is enough. This is enough. Why? Newton is a SI unit, okay? Pay attention. Newton is a SI unit, okay? It is there just to make our life easy. Otherwise, Newton is a complex combination of some other fundamental units. But Newton's is the main unit that we use to measure the force, right? So it's okay to keep Newtons here, okay? It's okay to keep Newtons here. Clear? I just ask you to write the unit of G in SI units. So Newton is a SI unit. Clear? R measured in meters. It is a length. Here kilogram squared. So you get kilogram minus 2. Clear? Then like if you need to go further, you can do this. What? So this is the unit of G, okay? This is the unit of G. Pay attention. This is the unit of G. Then, I mean, if you like, you can simplify Newton further. How? F equals ma. F equals ma. So, mass is measured in kilograms. Mass is measured in kilograms. Okay. Acceleration means meters per second squared. Clear? So this is the actual unit of force then. So this is equal to newtons, okay? This is equal to newtons. Got the idea? This is equal to newtons. Clear? Got the idea? So instead of newtons, I can write this if I need, okay? Newton means force, so from this side Newton means this. That means Newton means this. Clear? So if I need, I can do that. Instead of newtons, I can write that. Kilogram meters per second squared. Then here you have m squared. Then you have kilogram minus 2. So I can simplify this further. How? Kilogram, this is to the power 1. This is minus 2. Clear? This is minus 2. See? Kilogram, there's 1 kilogram here, kilogram minus 2 here. Clear? Then you have meter here and another meter squared here. Then you have s minus 2 here. S minus 2 here. Clear? Then you solve this, you get what? This kilogram minus 1. Kilogram to the power minus 1. Here meter cube. Here meter cube. Here s minus 2. S minus 2. Clear? You can solve this further if you need. But this answer is sufficient, okay? This is sufficient. Question 5. Question 5. F equals 6 pi. F equals 6 pi neta. The symbol is neta. AV. AV. All these equations are equations that you are going to see in future lessons, okay? Pay attention. Okay. F equals 6 pi neta AV. Then here, F is force. That means measured in newtons. A is they have given A as a radius. A is a radius, that means a length measured in meters. V is a velocity. Velocity is measured in meters per second. What is the unit of neta? 6 is just a number. Numbers are unitless. 6 is not a physical quantity. It is just a number. Then pi is just a number, right? Clear? Pi is just a number. So what is the unit of neta then? Here I have F over 6 pi AV. F over 6 pi AV. Then F is measured in newtons. 6 is unitless. Pi is unitless. A is measured in meters. V is measured in meters per second. Now solve this. I can get newtons. Here meter squared, pay attention. Newton meter squared per second. Newton meter squared per second. Clear? Then you take everything up. Newton per meter squared second. Clear? S minus 1 becomes S1 here. M to the power 2 becomes M to the power minus 2. Then you have newtons here. Clear? 8. 8. Okay. Moving forward. Question 8. Question 8. Question 8. Q equals ms theta. Q equals ms theta. Q equals ms theta. If Q is the amount of heat, if Q is the amount of heat, m is mass, theta is the change in temperature, what are the units of S? Q equals ms theta. So as I mentioned, Q is heat. Pay attention. Pay attention. Q is heat. Heat means energy, okay? Heat is a type of energy, okay? So energy is measured in what? Joules, right? Heat is, or any energy is measured in joules, clear? So energy is measured in joules. M, mass is measured in kilograms. Mass is measured in kilograms. Theta is something related to temperature, right? Temperature is mainly measured in kelvins now, okay? You can write Celsius if you like. But last week we learned that the main SI unit is Kelvin, right? Main SI unit is going to be Kelvin. Clear? Got the idea? Main SI unit is Kelvin. So you get Q is measured in, energy is measured in joules, mass is measured in kilograms, theta is measured in kelvins, okay? Theta is measured in kelvins. Got the idea? So S, units of both sides should be same. So S equals Q over M theta. Q over M theta. So you get the unit as joules over M is kilograms. M is kilograms. Theta is kelvins, okay? M is kilograms. Theta is Kelvin, okay? So we get joules per kilogram per Kelvin. Joules per kilogram per Kelvin. That is the unit of S. Clear? Okay. Got the idea? Joules per kilogram per Kelvin. It's time for the interval now, right? I mean, the first day we gave interval and nobody were in a hurry to stand up and get the interval. So we thought that you don't need an interval. Right? Who needs the interval, by the way? Properly? See, there's around 50% of the class. See, I maintain a 50% A percentage. Can you remember? So that's how it starts. Okay? That's how that 50% starts. Again, the people who need interval. See? Okay. So the next one. Question. What was the next number here? 11. Okay, I'll quickly do 11 and give you the interval. Okay. I'll quickly do 11 and give you the interval. F equals BIL sine theta. F equals BIL sine theta. What is the unit of B? F is measured in newtons. Pay attention. Pay attention. F is measured in newtons. I, it's a current, right? So amperes. L is a length, right? So meters. Sine theta is unitless, right? Can you remember? Sine theta is unitless. Clear? They are asking the unit of B, right? So B equals F over I L sine theta. F over I L sine theta. F over I L sine theta. So F is measured in newtons. I is measured in amperes. L is measured in meters. L is measured in meters. Sine theta is unitless. Sine theta is unitless. Length is measured in meters. Current is measured in amperes. Force is measured in newtons. Clear? Clear? So we get Newton per ampere per meter. Newton per ampere per meter. Clear? Got the idea? Newton per ampere per meter. So next you can try question 15, 16 and 17. Question 15, 16 and 17, and in the question tute. In the question tute, that means question tute in the sense this is in the exercise 2. This is in the exercise 2. And in the single page tute, try question 5 maybe. Try question 5. And maybe 3. I'm not going to do both today, but you can try. Question 5, question 3, and in the exercise 2, question 15, 16 and 17. I'll give you the interval. Time is, yeah, let's start around 5:30. Try these questions. Try the question numbers given. Question, let's start the discussion. Exercise 2, question 15, 16 and 17. Check whether there's a small delay here. Quickly check that. Okay. Exercise 2, question 15. Exercise 2, question 15. Online students, if you have any issues, inform us. Sure. Inform us if you have any issues. Okay, we'll check that. Try these question numbers. Exercise 2, question 15, 16, 17 and question 5 and 3. Question 5 and 3 of that single page tute. Try to get the answers quickly. If you're done with those questions, finish exercise 2, okay? If you're done with those questions, try to finish exercise 2. Online students, everything's fine, right? If there's any issue with the Zoom meeting, you can shift to the YouTube live. Provide the YouTube live link in the Zoom chat. Okay. Few students mentioned some issues. Okay, I think majority have no issue. So if you find it hard to see something, or if you can't see something clearly, shift to the YouTube live quickly. Exercise 2, question 15. H equals VL squared V S equals VL squared V L squared VL squared K2 minus K1 is equals VL squared K2 minus K1. Okay. I'll provide the YouTube live link quickly. S equals VL squared K2 minus K1. If S is the displacement, S is displacement measured in meters, then V is velocity measured in meters per second, meters per second. L is length measured in meters, so L squared means meter squared. Find the units of K1 and K2. What are the units of K1 and K2? They need us to find the units of K1 and K2. Okay. So, only. Okay, so the question is units of K1 and K2. So it's quite simple. How? Now see, first fundamental unit of this term, pay attention, is equal to the unit of this term, is equal to the unit of this term, right? Clear? Pay attention. Unit of this term is equal to the unit of this term is equal to the unit of this term, right? These three terms should be equal, right? They should have the same unit. So definitely unit of K1 is equal to the unit of S, right? Definitely the unit of K1 is equal to the unit of displacement, right? Sorry, unit of S. Clear? Unit of K1 is equal to the unit of S. Okay. So what is the unit of S? It is meters, right? Unit of this is equal to the unit of this. So this is meters. Then again, the unit of this is equal to the unit of this, right? Again, the unit of this term is equal to the unit of this term, right? What is this term? That term is meters. Clear? That term is meters. Equals, what is the unit of V? Meters per second. What is the unit of L? Unit of L is meter. L squared means meter squared. L squared means meter squared. Then we have unit of K2. We have unit of K2. Clear? This is meters. This is meters per second. This is meter squared. This is unit of K2. Clear? Then we get unit of K2 equals M over M S minus 1 M S minus 1 M over M S minus 1 M squared. Clear? M over MS minus 1 and M squared here. That is the unit of K2, right? That is the unit of K2. Then we are going to get what? Then we are going to get meters and meters cancel out. S minus 1 becomes S. This becomes M minus 2. This becomes M minus 2. Clear? S minus 1 becomes S. This becomes M minus 2. Continue the questions. Continue doing the questions. Ali. Just I'll do the 15th one again. Okay. So the idea is this. So online students, if you find any issues on the Zoom meeting, you can shift to the YouTube live one. You can shift to the YouTube live one if you need. Okay. So moving forward, I'll explain this again. There are some questions related to this. S equals VL squared K2 minus K1. Okay. Can you remember for a equation to be correct? For a equation to be correct. For a equation to be correct. For a equation to be correct, all the terms should be same, right? Okay. If you have an equation like this, okay. If you have an equation like this, okay. This term and this term should have the same units, right? If this is meters, this should be meters and this should be meters, right? All the terms must have the same unit, right? Clear? All the terms must have the same unit. Clear? This is meters, then this should be meters, then this should be meters. Clear? All the terms must have the same unit. So then okay, moving forward, pay attention, pay attention. Moving forward, so in this one also, unit of this term must be equal to the unit of this term, must be equal to the unit of this term, okay? Unit of this term, pay attention, must be equal to the unit of this term, must be equal to the unit of this term. Clear? Clear? So here, why? These are separate terms. But to subtract these two terms, unit of this term should be equal to the unit of this term. If it is equal to this, that means unit of this term is equal to the unit of this term is equal to the unit of this term. Clear? Got the idea? So as a result, unit of this term S should be equal to the unit of K1, right? Otherwise, this equation can't exist. Okay? Unit of this term should be equal to the unit of this term. Clear? So that means if S is meters, unit of this term should be equal to the unit of this one. So unit of K1 should be equal to the unit of S. That means meters. Clear? That means meters. Got the idea? The students who asked the question? That's how, I mean, a equation is correct if all the terms have same units, right? Clear? Okay. Then the next one, pay attention. Then the next one is here. Unit of this term is equal to the unit of this term. So unit of this term is meters. Unit of this whole term should be equal to that. So unit of this term is meters. What is the unit of this full one? V means meters per second. L squared means meter squared. This is unit of K2. Then unit of K2 equals M over M is minus 1 and meter squared. Okay. And online students, wait for a second. Okay. We are going to shift the connection. So wait for a second. Okay. Okay, now everything's clear, right? Now everything's clear, right? Online students? Okay, cool. Next one. Next one. Question 16. Question 16. X equals P plus QT. X equals P plus QT. If X is the displacement, pay attention, X is displacement measured in meters, T is the time measured in seconds, T is the time measured in seconds, what are the units of P over Q? What are the units of P over Q? So in this case, pay attention, unit of X should be equal to the unit of P should be equal to the unit of QT, right? Unit of this term, unit of this term, and unit of this term should be equal. Clear? Otherwise, you can't have an equation like this. Clear? Unit of all the terms should be equal. Okay? Then we can tell something like this. So, unit of P is equal to the unit of Q and T, right? So, now you can tell unit of P is equal to here unit of Q into time. Unit of time is seconds. Clear? I can forget this side. In this side, I can tell unit of P. In this side, I can tell unit of P. Clear? Equals unit of Q into unit of T. Seconds. Unit of this term and unit of this term should be equal. Clear? Clear? That means they need us to find what? Units of P over Q. That means unit of P over unit of Q, right? Clear? They need us to find unit of P over unit of Q. Clear? That means S seconds. Clear? Unit of P over unit of Q equals seconds. T is time, right? Yeah, T is time. This side, I don't have to think about this side, right? I don't have to think about this side. Why? Unit of P should be equal to unit of QT. Unit of P equals unit of Q into time is seconds. So unit of P over unit of Q equals seconds. Clear? Got the idea? Clear? Sorry? I mean, no point of using X, right? It's somewhere else, I mean. It's placed somewhere else. So you will anyways get the same answer. Whatever the method you use, you will get the same answer. Okay? But I mean, to create the relationship between P and Q, I just need this, right? Clear? I mean, for an example, I mean, I can use something like this. Okay. This is, pay attention, stop talking. So this is meters. This is meters. Then P is in meters, right? If this is meters, if X is measured in meters, unit of P also meters, right? Unit of P is also meters. Clear? Why? If this is meters, this can't be kilograms, right? If this is meters, this should be meters. Then unit of P is meters. No issue there, right? Then here again, this is meters. This side is meters equal to what? Unit of Q. Then time is measured in seconds. Unit of Q into seconds equals meters, right? Why? Unit of this term and unit of this full term should be equal. Clear? Clear? Then what do I get? Unit of Q equals meters over seconds. Clear? Which means meters per second. Clear? Which means meters per second. Then Then unit of P, now unit of P over unit of Q equals what? Unit of P over unit of Q equals meters over meters per second. See? Anyways, you are getting the same answer. Yes. Clear? Anyways, you are getting the same answer and no point of using x here. Yeah? Clear? No point of using x here. Why? You can just combine these two. Clear? Got the idea? Ah. And who are the guys who are good at cricket? People who can play cricket? Okay. The one next to me can play cricket? No, we have a match in April. That's why we need teams from 28 batch too. Okay. We have a cricket match in April. And I mean, everyone is welcome, by the way. That means it's not only cricket. I mean, the 27 batch specially requested for a rugger match. So we are having a, I mean, the 27 batch, I don't know about this batch yet. I mean, the 27 batch is just killers. Okay. I mean, they need to kill people, fight. I mean, that it's that kind of a class. Okay. So, I mean, every day we have some kind of a problem. Okay. Someone has tried to kill someone, or someone's parent is here. Someone's parent is, I mean, that parent is going to kill me and others. Okay. Then our staff have to interfere. So it's just a bunch of drama. Okay. So they need, I mean, they need something harmful. So they don't like cricket. So we have rugger too. And girls requested another set of sports. So yeah, there would be a bunch of sports. So, and online students are also welcome. Okay. I mean, not to watch online, but come here. Okay. So that is the idea. So start like forming teams. Okay. We'll inform the exact number. Start forming teams. Okay. I mean, nowadays Sri Lankans are not good at cricket. We know that. But I mean, still we are a country that used to play cricket, right? Okay. Okay. Question 17. Oh, that question I gave. Let's try that. I can't remember the question I gave. Pay attention. I can't remember the question I gave. It was, sorry, I can hear a lot now. Sorry. Okay. Now tell. No, this is not gonna work. Just show me the question. Anyone have the question? Yeah. Okay, it is f over b. It is f over b. F over b equals am 5 to the power a r t. Pay attention. Stop talking, everyone. Pay attention. F is a force measured in newtons. M is a mass, right? Yes, right? It is measured in kilograms. R is radius, which is a length measured in meters. T is time measured in seconds. I asked you to find the unit of B, right? I asked you to find the unit of B. Clear? I asked you to find the unit of B. So how can we get the unit of B? How can we get the unit of B? It's like this. I mean, there are two unknowns here, B and A. Both are unknowns, right? Both B and A are unknowns, clear? Both B and A are unknowns, clear? But I know one thing, that is, a power can't have a unit, right? A power can't have a unit, clear? A power can't have a unit. 5 to the power something can't have a unit, right? That means unit of A into unit of R, which is meters, into unit of T, which is seconds. Unit of A into unit of R, which is meters, into unit of time, which is seconds. Clear? Unit of A into unit of R, which is meters, into unit of time, which is seconds, equals nothing. There shouldn't be any unit, right? Clear? A power can't have a unit. A power can't have a unit, right? So unit of this into unit of this into unit of this means nothing. All the units should disappear. Clear? All the units must disappear. So I can find the unit of A. How? Unit of A equals, I'll keep 1 here. Take meters and seconds here. Okay? Take meters and seconds here. Then we are going to get per meter per second. Unit of A equals per meter per second. Clear? Got the idea? Per meter per second. Now what? Now I know the unit of A. Okay? Now I know the unit of A. Now let's find B. Okay? F over B equals A M 5 into ART. So ART is just a number, right? It's just a number. It should be unitless. Then 5 to the power number, again unitless, right? 5 to the power something can't be a unit, right? 5 to the power something, again unitless, right? 5 to the power 5, it's 25. Not a mass, not a length. 5 to the power 5 is 25, that's all. So this part is entirely unitless, clear? So if this part is unitless, what should happen is these units should match, right? These units should match. What is the unit of F? Newtons. Unit of B? That's what I need to find. Unit of A? I just got that. Unit of A, I just got that. Clear? This is unit of A. Clear? This is unit of A. Per meter per second. Per meter per second. And unit of M? Unit of M is kilograms, right? Unit of M is kilograms. And this part is unitless, clear? This part is unitless. Got the idea? Then we are going to get unit of B equals what? Newton per meter per second and kilogram, okay? Per meter per second, here Newton, then here per meter per second and kilogram, clear? Then you solve this, you get, I took UB here and took this stuff here, N over this stuff, took UB here, then Newton per meter, you take it here, that becomes meter. Per second, you take it here, becomes seconds. Kilogram, you take it here, per kilogram. Per kilogram. Clear? Got the idea? Per kilogram. And online students, if you didn't receive the tooth set, if you send the message, don't send this again, okay? Otherwise, you will receive like 10 tooths at the end of the day. If not, send a message to this number, 070 786 6277. 070 786 6277. Mention your name, address, a phone number that is working, okay? Phone number, your batch, mention that as 2028, otherwise you will receive electronic tubes. Then the medium, English medium or Sinhala medium, okay? Just inform our people if you need us to explain this again. Just mention the number, okay? Or write a sheet. Okay, write on a piece of paper if you have any issues, or inform our people. They will inform me. At least if 2 students or 4-5 students ask the same question, that means I have to repeat that, right? So you just have to mention, that's all. Just ask our invigilators to mention that again, okay? Then if there's many requests, they will quickly come and inform me, then I can explain things again, okay? So that's the whole point, okay? I can't assume, okay? I can't assume. I can't keep assuming stuff, okay? So you just have to inform me whether if you didn't understand. If there's enough request, I'm gonna explain things again, okay? Yeah. Yeah, that's the issue here, right? Thank you for that. This is unit of A. This should be kilograms, right? I just wrote meters here. That is error here, right? Yeah. That is error here. So thank you for that. Pay attention. But this is the first one, unit of A. This is unit of meters. This is seconds. Okay, no big issue here. Then we are going to reach here, F over B, AM. This is unitless. Then F is in newtons, unit of B. A means per meter per second, and M is as kilograms. Then it's okay. And then it's correct, right? No issue here. Yeah. So, I mean, pay attention properly. First, I got this part. That part is unitless. This is the unit of A. Unit of R is meters. Unit of time is seconds. Then unit of A is going to be 1 over meters and seconds. That means per meter per second. That is from this part. Then anyways, this part is unitless. Then units of this side should be equal to the units of this side. Here, unit of F is newtons. Unit of B, UB, that I need to find. Unit of A, per meter per second. Then unit of M here is kilograms. Clear? Then I'm going to take unit of B here and take these guys here. Newton over per meter per second and kilogram. Clear? Then I'm going to take everything up. Newton, this becomes meters, this becomes seconds, this becomes per kilogram. Clear? Got the idea? No issue, right? Just mention if there's many questions. Why did you set value of ART as 1? See, ART is unitless. Why? Pay attention. This is a power. 5 to the power something. This should be unitless. Unitless means 1. Unit is 1. That means there's no unit. Clear? There's no unit. It's just 1. So unit of A into unit of R, that means meters into unit of time, that means seconds, is unitless. That means 1. Clear? I just write unitless as 1 so that I can solve things, right? So that I can solve things. So unit of A into meters into seconds equals 1. Clear? Then I take these two down here. Clear? Got the idea? Clear, everyone? Okay. Moving forward. Let's discuss question 17, then move to that tute. H rho G, H rho G equals 2T over R. Pay attention, everyone. Pay attention. Stop talking. H rho G equals 2T over R. H is height, rho is density, G is acceleration. Here 2 into T into R. What is R? R is radius. So H is height, right? That means measured in meters. Rho is density, is measured in kilograms per meter cube, right? Density is measured in kilograms per meter cube. G is acceleration, right? Acceleration means meters per second squared. 2 is a number, unitless. R is a length, right? A radius. That means measured in meters. Clear? Measured in meters. Got the idea? Then I can write T equals H rho G into R over 2. H rho G into R over 2. Clear? So we get unit of T. Your parents are already there, I think. What is the time? Yeah. See? Okay. Unit of T equals H measured in meters, rho density, kilogram per meter cube, G meters per second squared, H is measured in meters, rho kilogram per meter cube, G is meters per second squared, R is measured in meters, R measured in meters, 2 is unitless. 2 is unitless. Clear? Pay attention, stop talking. So you have to be silent when I'm teaching, okay? Otherwise, some 27 batch people have permanent residencies here, around here, okay? Ask your parents to be patient. Okay? So we get here meters, and meters, meter cube. Meters, meters, and meters. Meter cube. Then meter minus 3. Then we have kilograms here. Kilograms here. I consider this, and this. Then meter minus 3. Kilograms here. Then S minus 2. So M minus 3 and M into 3 will cancel out. Then we have kilograms per second squared. Kilograms per second squared. Clear? Kilogram per second squared. Question? Did I make any mistake? Really? Wait. Where? Here? Here? Really? The answer given is different. So did I make any mistakes? H rho g equals 2t over r. Yeah, it should be different. Tension is surface tension coefficient. That means newtons per second squared. No. There should be a meter here, right? There should be a meter somewhere here. Where did we miss a meter? 1, 2, 3. No. It's correct. It's correct. Surface tension coefficient. I know the physics here. That means, what comes, all these are equations after that. So I can think that way. All these are equations that you will see in the future. So this is surface tension coefficient. That means force per unit length. I think I'm correct, right? I didn't make any mistakes, right? So this is correct. So the answer is wrong. Yeah. That's how the whole science stream works, okay? In my class, what I'm telling is right. If the answer script is different, then the answer script is wrong. Okay? No, it's not like that, okay? We can make mistakes. But this one is correct, okay? Pay attention. What I discussed was whether we are starting that maths for bio student session by next week or not. Class starts at 3 to 6:30. Pay attention. And anyways, next week a few more invigilators will be available, okay? What we understood was we don't have, the number of invigilators are not enough. That means can't help, okay? The count grows, we can't predict, okay? We can't predict. I think today's student count is like twice of last week, okay? So we can't predict. So by next week, more invigilators will be available. It's good that you ask questions. And in the future, you will have more questions, okay? Your whole existence and your whole choices will be a question for you, okay? Oh, visible. A question? Okay, pay attention. Pay attention. Uh, but we don't have enough time, right? Did we get the WhatsApp numbers of new students? Then we don't need that, right? We don't have enough time today. I mean, their parents gonna kill someone there. Now we have 5 minutes. And I'm gonna discuss one more question, okay? The class is not over. Okay? Uh, pay attention, pay attention. I mean, there's nothing else you can, I mean, you just go home and do something, I mean, useless, right? So, you should not have a hurry to go home, right? No one's gonna do something useful after going home, right? No, right? So, just wait. Pay attention. Now, we can start Maths for Bio student sessions from next week. I'm still thinking whether it's too early or not. And we have to discuss a date too. And a time. Okay, let's do it this way. No. Wednesday. Wednesday, I'm not here. I'm in Ratnapura Wednesday. Yeah. So one of the ideal plans would be doing this before the class. Maybe take 2 hours before the class and do that connected with the class so that you can come to the session and stay in the class and go home. Anyways, a bunch of students would miss. Okay, whatever the session we do, anyways, a bunch of students gonna miss. And the recordings are gonna be available, okay? These are going to be 2-hour sessions for a few weeks to teach the required maths part, especially for bio students. And the maths people, you are not good at maths yet. So, yes, welcome. Okay. So, we'll provide the information in the group. If we are starting next week, I'll inform in the group. If we are starting, it will be from it should be from 12:30 to 2:30 maybe. Then we can start the class at 3, hopefully. Yeah, on Thursday. Sorry, on Tuesday, yeah. Is it too difficult for you to handle 5 hours? You will have better problems in the future, but now I think yes. Okay, we'll discuss it later. Okay, no point of discussing with you guys. So, so it will happen within the next week. We are starting. So most probably I'll provide a poll in the group to get the dates for this and the time for this. Class is not over. I'm going to discuss one more question. Okay. You have to get your books out again. Okay. Can't help. The class is not over. So, yeah, I'll provide a poll in the group, get information, and by next week, let's start the Maths for Bio student sessions to teach all the essential maths concepts. Let's figure out the date in the group, then move forward. You will be added to the group, all the online and physical students too. Let's do it that way. And let's move to this question quickly. Question 5. One more question, one. Okay. Of this tute, question 5. I'll quickly show you a method, then you can try it, okay? I'll quickly show you a method, then you can try. Okay, oh. I'm not good at drawing circles. Okay. So gonna take a while for this. Okay. Okay, cool. Anyways, a sphere and an egg. Okay. There's a square here. There's a square here. They are asking the area of the square. I'll tell you a method. Take this line. Take this line. Okay. If side length of the square is x, zoom here, then this is going to be x over 2, right? Then the radius is 5. If the radius is 5, what is this part? What is this part? If the radius is 5, if this is x over 2, this is 5 minus x over 2, right? Okay. If this is 5 and if this is x over 2, this is going to be 5 minus x over 2. Clear? Okay. Then again this is 5. Okay. Again this is 5. Clear? That is 5 and what is this? This is a square, so this is x, right? Clear? So this is 5 minus x. Then this is 5 minus x over 2 and this is 5 minus x. Clear? And this is again the radius, which is 5. It's a Pythagoras triangle. Did you understand? Did you understand? Now it doesn't look good. But drawing two circles would cost a lot of time. And some teachers are there who are against doing these kind of stuff. Telling that it's not physics, students get afraid for this kind of stuff we hear a lot. I mean, that's not my problem. I mean, hopefully at the end of the day, as a result of doing science, the ultimate expectation is having enough intelligence, okay? That's all you're gonna get, okay? If you go to a company to work as an engineer, no one will ask you to find the unit of this. Okay? So the total idea of doing science is being intelligent than others. So I'm not going to stop this kind of stuff, okay? But I see a lot of, okay, there's a lot of noise going on, okay? What is the point of doing this kind of stuff? It's not physics. Students get afraid for physics when you do this kind of stuff. Not my problem, okay? I mean, some people have that kind of a, issue from birth. Some people are not born with brain, so without brain. So we can't, think about them, right? You are good students, you are capable students. Everyone here have the capacity to be someone better, okay? You are not going to be ordinary, okay? Don't do that, okay? You are going to be special. For that, you have to strive. For that, you have to improve your brain capacity. For that, we have to do this kind of stuff. Just because of there are few people out there who have brains that cannot be developed, we shouldn't think about that, right? It's not our problem. You guys are capable, everyone is capable. So we should go there, okay? We should go there. Just don't listen to that noise, okay? Because I hear that every year. What is the point of doing these kind of questions? Just because my students have enough brain to handle that. Okay? Because every year I hear that, don't go to my class. We do different questions. Then students get frightened to science. This is science. If you're afraid of this, yes, you should be afraid of science. Okay. Science is thinking, okay? So again, a quick idea. This is 5. This is 5. Half of it is x over 2. Clear? This is 5. Half of it is x over 2. So this is going to be 5 minus x over 2. That means this length is going to be 5 minus x over 2. Clear? Then this is 5 and this is x. Clear? This is 5. Okay? This length is 5. Clear? This is x. Clear? This length is 5. Sorry. Wait. This is 5. This is x. Then this is 5 minus x. Clear? This is 5 minus x. This is 5 minus x over 2. Clear? And this is again the radius, right? This is again the radius, which is 5. Clear? Then this is a Pythagoras triangle. Clear? Clear? So I can write this 5 minus x squared plus 5 minus x over 2 squared. This is 5 minus x squared. This is 5 minus x over 2 squared equals 5 squared, right? Clear? 5 minus x squared plus 5 minus x over 2 squared equals 5 squared. You solve this equation and you get x, okay? If you know x, you know the area. Area is x squared. Area is x squared, okay? I'm not going to continue, okay? You can solve this. Try to solve that. And like, don't listen to the noise, okay? That is very important, okay? Go to classes that always do difficult sums, okay? That is the whole point of doing science. You have that capacity to grow, okay? You guys have brains that could be developed. So don't block that, okay? Always try to do difficult questions. That's all from my side for today. Let's meet next week. Nothing special for this week. There are a few questions that you can try in the book. Did I miss anything? No, right? Bye. Yes, to join the group online students, send a message to this number. Send a message to this number to join the group. Note 701546825. Note 701546825. Send a message to this number. Thank you.